The last part of our section on applications of quadratic equations is going to involve projectile or motion problems, including finding maximum or minimum values. And in order to work with problems of this type, we need to understand the projectile motion equation, which is given as S equals negative 1/2 g times t squared plus v sub 0 times t plus s sub 0. And we're going to need to define each of those variables so that this is making sense. And I'll do so from left to right. So first, s is going to actually help us understand the position of the object. And notice that this is in terms of t. So S is going to give us the position of the object at time t. G is acceleration due to gravity. And on Earth, gravitational force is going to be 32 feet per second squared, or 9.8 meters per second squared. So you're going to have to be aware of your units. T is time, and that is in seconds. V sub 0. Now the sub 0 is also known as V naught, and that is the initial velocity or speed. And initial means start, and so that means when t is 0. And then S sub 0 is the initial position. And again, initial is the starting time, and so that is when t equals 0. We can think about it's when the experiment is beginning. Okay, so that's what we need to be able to use for our problems together. So for our first example, the distance d in feet required to stop a car that was traveling at speed v. So that's our variable. In miles per hour, before the brakes were applied, depends on the amount of friction between the tires and the road, as well as the driver's reaction time. So based on collected data, the stopping distance can be modeled by the equation d equals 0.05 times v squared plus 2.2 times v. So we are going to first determine the distance required to stop a car going 40 miles per hour. So the information that we're given is the velocity or speed of the car. So we know that v equals 40, and we're trying to figure out what d is, which is the amount of distance it takes for this car to actually stop. So we're going to let v equal 40. So that means d is equal to 0.05 times 40 squared plus 2.2 times 40. And when we substitute this into our calculator, we get d is equal to 168. Now you have to be careful. Notice that the speed was given in miles per hour, but would this make any sense at all for us to say that it would take 168 miles for this to stop? So notice that d, the formula, is actually given in feet. So it takes 168 feet for this car to stop if we are going 40 miles per hour. So I want you to think for a moment for part B. If it takes 168 feet for a car to be able to stop if the driver was going 40 miles per hour, was a motorist going slower or faster than 40 miles per hour if it's going to take that motorist to stop the vehicle a distance of 330 feet? So I just want you to take a moment. Was the motorist going slower or faster than 40 miles per hour? We know at 40 miles per hour it's going to take 168 feet. So was the motorist going slower or faster than 40 miles per hour? And I'm hoping that you recognize that the motorist is going faster because it is taking a longer distance. Okay, so that leads us into the next question. So that helped us understand that the motorist is going faster than 40 miles per hour, but we can actually figure out the speed of the motorist. And so what speed was the motorist going if it took 330 feet to stop? Well, 330 feet is our distance. So the distance equals 330. We're actually looking for the velocity. So we're going to use our equation and we're going to let distance equal 330. And this is equal to 0.05 times v squared plus 2.2 v. And we're going to recognize this is a quadratic equation, and in order to solve for v, we need to set this equal to 0. So 0.05 times v squared plus 2.2v minus 330. And I have no idea if this is factorable or not, but I do know that I have other tools for solving quadratic equations, namely the quadratic formula. So v is equal to negative b. Well, let's take a moment. A is equal to 0.05. B is equal to 2.2. C is equal to negative 330. So let's start again. V is equal to negative b, so negative 2.2, plus or minus the square root of b squared minus 4 times a times c. And I'm going to extend my radical. And then this is all over 2 times a. So using our calculator, (2.2) squared. Now this will become actually plus, won't it? Because it's minus a negative. So plus, and that's going to give us 70.84. And then divided by 0.1. Now take a moment here and look at the fact that we have plus or minus. So we already have a negative 2.2. Now 70.84, that's a number that's going to be somewhere between 8 and 9. And that's because 8 squared is 64 and 9 squared is 81. So we cannot subtract this radical. So v is going to have to equal negative 2.2 plus the square root of 70.84. Now figure out what that is and then divide by 0.1. So I actually want you to take a few seconds here. Remember to put in your calculator negative 2.2 plus the square root of 70.84. I would press enter and then divide by 0.1. Now, we made the hypothesis that this is going to be a speed more than 40 miles per hour. And if we calculated this correctly, and please make sure, hopefully I did my calculations correctly, this is giving me 62 miles per hour. And I'm not getting any red flags here in the sense of I was expecting a number greater than 40 miles per hour, and I got a number greater than 40 miles per hour. Our next question. A horseshoe is thrown upward from an initial height of 2 meters with an initial velocity of 8 meters per second. And so we're going to use the projectile motion equation to create the position function of this horseshoe. So because this is in meters, that means our gravity is 9.8 meters per second squared. The initial height was 2 meters, and the initial velocity is 8 meters per second. So that gives us S is equal to negative 1/2 times 9.8 times t squared plus 8 times t plus 2. And simplifying, negative 1/2 of 9.8 is negative 4.9 times t squared plus 8t plus 2. And so that's our position function. So if I want to know the height of the horseshoe after 1 second, what is the 1 second? So we're letting t equal 1. And we want to know what S is. So S is equal to negative 4.9 times 1 squared plus 8 times 1 plus 2. Now 1 squared is just 1. And 1 times negative 4.9 is negative 4.9. And then we have plus 8 and plus 2. And simplifying this, this gives us a height of 5.1, and then remember this is all in terms of meters. How long after the horseshoe is thrown will it be 4 meters? Now remember, we only have 2 variables here, either S or T. Is this S or is it T? It's not time, is it? So this is our S, and we're trying to figure out the time. So we are trying to determine T when S is 4. So using our equation, we have 4 is equal to negative 4.9 times t squared plus 8t plus 2. And we're going to set this equal to 0. And I'm actually going to choose, because this is a negative 4.9 times t squared, it is easier for us to use our quadratic formula with a positive a. So I'm actually going to add the 4.9 times t squared to the left side. I'm going to subtract the 8t, and I'm going to subtract the 2 combining with the 4. And now we have A is 4.9, B is negative 8, and C is 2. And for space sake, I'm going to use my quadratic formula over here. So T is equal to negative B. That actually gives us a positive 8 plus or minus the square root of b squared. Well, negative 8 squared is positive 64 minus 4 times a, which is 4.9, and times c, which is 2. And this is all over 2 times a, which is 4.9. So t is equal to 8 plus or minus, and 64 minus 4 times 4.9 times 2 gives us 24.8. Now that is very, very close to 5, isn't it? Because 5 squared is 25. So we're going to actually accept both of these answers. So we're going to accept the plus of this radical and the minus of this radical. And this is divided by 9.8. So we're going to have two operations in our calculator. We're going to have 8 plus the square root of 24.8 divided by 9.8. And if you calculate that, that gives us about 1.3 seconds. And then we're also going to have t equals 8 minus the square root of 24.8 divided by 9.8. And that is about 0.3 seconds. And I want you to think about the fact that this horseshoe started at a height of 2 meters. And so when it's going to be 4 meters, is when it's going up as well as when it's coming down. So that's why we're getting two answers there. Now, how long will it take for the horseshoe to reach its maximum height? Now remember, this is a quadratic function, and because a is negative originally, so we have s is equal to negative 4.9 squared, 4.9 times t squared, plus 8t plus 2. Because a is negative, that means that this is opening down, which is why we can talk about maximum height. So in terms of how long it's taking to reach the maximum height, that is looking at t. And so t is actually the equation for our axis of symmetry, which is negative b over 2a. So t is equal to negative 8 over 2 times negative 4.9. And so t is approximately 0.8 seconds. And then in order to find the maximum height, that depends on this value. So s of 0.8 gives us our maximum height. So when we calculate that, it is about 5.3 meters high. So that gives us the maximum height. And then final question, how long after the horseshoe is thrown will it hit the ground? Well, hitting the ground is talking about the position, and if it's hitting the ground, that means the position is 0. And how long, we're asking to find the time. So we're going to set this equal to 0. And to make it easier for us for using the quadratic formula, let's negate everything. So because this is now set equal to 0, we can multiply through by a negative, or divide by a negative, or just make everything negative. And so that gives us t is equal to 8 plus or minus the square root of negative 8 squared, which is 64, minus 4 times 4.9 times negative 2, all over 2 times 4.9. So t is equal to 8 plus or minus the square root of 103.2 over 9.8. Now, notice the fact that the square root of 103.2, that's a little bit more than 10, isn't it? Because 10 squared is 100. So for that reason, we reject the minus. So t is equal to 8 plus the square root of 103.2 divided by 9.8. So remember from our previous example, part C, we know that it's going to take more than 1.3 seconds to hit the ground, because at 1.3 seconds it's still 4 meters above the ground. So we're looking for a number more than 1.3. And when we do our calculation here, we get approximately 1.9 seconds. And I know that this one's our longest video so far, and I apologize for that. There's a lot to cover, and I also always like to give you time to process. So for the rest of the material, these are all questions for you to handle. So for our first set of questions, the height of an object launched upward at a speed of 32 feet per second from a height of 6 feet. Now I have constructed the function for you. So our height function is negative 16t squared plus 32t plus 6. So you are asked for the starting height of the object. And second question, you are asked for the height of the object after 2 seconds. Next set of questions, the height of a projectile launched upward at a speed of 64 feet per second from a height of 128 feet is given by the function h of t equals negative 16t squared plus 64t plus 128. I'm asking you to find how long it takes for this projectile to reach its maximum height, and then what is the maximum height, and then finally, how long does it take for the projectile to hit the ground?